Here's our test schedule. We have 4 exams and a final. Right, the exams will be on these dates. They'll be in class. They're not in this room. We'll move into the big auditorium, I think, if I can get it, so y'all can spread out a bit. And they're closed book. I think exam 2, I began introducing an equation sheet to you for you to use. I'll show you that. There is homework. I sent out a message about the workbook. I think maybe some of you have gotten, but most of you have not yet. But you probably on the way for many of you. You should get that. It'll really help you as you're going in the class because it has all the notes in it, has all the homework in it, has all the clicker questions that we'll do in it. It has a semester of old exams for you to work through that we'll also work through in class. It'll just make your class time a lot more efficient so you don't have to write as much, okay? So that's really the purpose for that. We will also be using an online textbook, which I'll show you. Oh, here's our calendar on your syllabus. It shows the exam dates, the holidays, and the drop date. This is our drop date, October 28th. We'll have 3 exams by then. So you'll pretty much know what your grade is by that point and whether or not you'll be possible for you to pass the class. Class participation. I don't take roll, though I will in the next couple weeks just to help figure out who's in the class and who's not. But we will use clickers, and that participation is worth 50 points. That's 50 out of 700. I think it's about 7% of your total grade. It is 7% of your total grade. I'll have questions in class, and you'll take your clicker and you'll answer what you think the answer is. And then I take all those questions at the end of the semester, and I add them all up, and I assign a value to each question. The way I assign that value is I say, what if there's a person in the class that came every day and answered all of the questions, and they only got half correct? Then that person would get the full 50 points. So you see, it's not a real high bar. You have to answer all the questions and get half of them correct. However, if you get more than half correct, the questions, when you get them correct, are worth double credit. Okay? Practically, almost everybody's going to get the full 50 points. There'll be a few people that are just shy of that. And then I know that probably 10% of you are just going to not come to class, and you're not going to do very well in the class because of it. So those people will be, 25, 30 points. I regret that, but that's typically the reality. Okay? So come to class and do your best on answering the questions. You can ask your neighbor. You can use your phone to look up the answer if you can. I don't know if you'll be able to. But you can talk to your friend, talk to several people, see what they put, and try to get the right answer. Okay? That'll become more clear as we go along. Every Friday you'll have a quiz. Some of you have already done your quiz for this Friday, a couple of you. I sent out a message about that. It's on this OpenStax tutor that I'll show you here in just a moment. There's our grading. These online quizzes, these are tutor quizzes, this homework system that we're using. Those are going to be worth a full exam. That's a lot, folks. That means you have 4 exams, but it really means you have 5 exams. And 1 exam is sort of cumulative as you go through the semester. Every quiz that you have on every Friday, which will be on your own time, online. You have until midnight on Friday every week to do it. That'll be worth 100 points total, all of them combined. So do well on those. You can work together. You can use any resource that you want on those, but it'll count like an exam. Yes?
Do you only have 1 attempt for the quiz?
That's right, only 1 attempt, yeah. So do the best that you can on them. Okay? Got it? All right, good. Makeups, if you miss an exam, it's important on exam dates that you come. If you miss an exam, there are 15 points deducted automatically from your exam grade. Unless it's an excused absence, it's documented. University absence, doctor's excuse, that sort of thing. All right? Is there a chair back there, y'all? There's 1. Are there any more? Oh, wait. Okay, and that's it for the syllabus. Any questions? Any other questions about the syllabus? Yes? The final is cumulative, all right? And the final is worth 150 points. Typically, I take the final from the 4 exams. Also, those questions that you'll be doing on the quiz Fridays, you'll see some of those questions on the exams as well. So that will benefit you. You'll certainly see questions like those, but I'll usually take, or I shall take 1 or 2 questions from those quizzes. Yeah, Drew? Don't think so. Pretty sure they're not. I'm new to this system. Pretty sure they're not timed. Any other questions about that? So if you go to the website, oh, let's see, a few other things here. This is advice from students on how to make an A. I'll let you read that on your own. It's also in the back of the book. They come to class, they study old tests, they do the homework, and they study the clicker questions that we do in class. That's what they do in short. If you're an honors student, there are some ways to get honors credit. I have some ideas. If you have your own idea, please bring it to me and I'll consider it. But you can petition this course for honors credit. I recommend that you do so. It's a good advantage, or a good option for you to get honors credit. How many honors do you have? Yeah, I usually have a lot, yeah. This is a good class, y'all. Like, the students in this class are the best students at Nichols. Did y'all know that? If you look at your GPAs, if you look at your ACT scores, you guys are the best of the best at Nichols. That's why I like it so much. This is that workbook I sent out. You can purchase it. This is the equation sheet that you'll have after chapter 4. I will record every class and put it on this website. This is our screencast site. You can also find recordings. I have an online class that runs parallel to this. Under online participation, you can go and you can find, for example, all the chapter 1 material. It's not real exciting. It's just sort of me talking through the material and going through the notes, but it is useful, like if you miss class. So I just have a screen. I can write on it just like I'll be writing on screen in the class here. Is that clear? If you miss class, you can go there and pick up where you left off. I think that is it for this website. There are other things you should go through and take a look at them, but they'll become apparent to you over the year. Questions? Okay. Oh, also, my wife and I, we're going to be hosting like I say it's a lunch. It's like a brown bag lunch. People often, when they hear us say that we're Christians and that we're scientists, they sort of think that that's strange. And so students often have a lot of questions. And so once a month, maybe twice a month, we'll see what the interest is. We'll have students that can come. We can just talk. We'll have it in the conference room on September 2nd on Friday. I'll announce it before, as we get closer that day. If y'all want to just come and grab some lunch at the Union and bring it back over in the conference room, it's right over next to the other classroom. And we can talk about whatever you want to talk about. We sort of think about it as like a science-based discussion. But any questions that you might have, we'll talk about it. It's not going to be confrontational. It's not going to be argumentative. We're pretty easygoing, laid-back folks. So just an opportunity for you guys to come and hang out and talk. Let's see. Now, we are going to do two things. Oh, no, I have one other thing. I'm sorry. So the OpenStax tutor, which I sent emails out about, I'm participating in a research program. I'm working with some folks at Rice where we're trying to assess the effectiveness of this OpenStax tutor homework system. I have really great expectations for it. I think it's going to help you to grasp the material and also sort of help you to stay on top of the material day to day. But we are doing this research program where we're going to use your performance data in order to assess how effective the OpenStax system is. Okay? It's up to you whether you want to participate or not in the OpenStax research. It's not up to you whether you want to participate in the problems. Everybody's going to do the quizzes every Friday over there. But it's up to you to decide whether or not you want us to use your performance data for this research project. Now your name and your student ID and all that stuff is completely going to be stripped away. So nobody will know who you are. They're just going to say, student A got this answer wrong. Student B got this answer right. That sort of thing. In order to do that, though, I need your consent to use your performance data. Not your name, not your ID number, not anything about you except like your gender, or your first generation student. That's Nichols has all that information. And also your performance on the quizzes. Okay, so I'm going to hand this out. I need you to sign it and just check the box whether you consent or you do not consent. I encourage you to consent to it, right, but I don't require it. I'm not even going to look at them. I'm going to scan them and send them to our research office. But I encourage you to do so. It's a help. Okay? So I'll pass these out. And please write your name on them and sign them, and then click whether or not you consent or not. Can you sort of spread this out, this section? You can just sort of like, y'all watch Plinko on The Price is Right?
Right.
Okay? Alan, understand what I'm saying? Make sure everybody gets one. So. Let me make sure that I think that's everything. OpenStax is a non-profit group. They're funded by Bill and Melinda Gates Foundation. They provide open source textbooks, free textbooks for college students. They're good textbooks. They're just as good or better than anything you'll pay $200 for back in the bookstore. I said all this. You don't have to consent. You have to be 18 years old. Sometimes I have high school students that, you don't have to tell me, but if you're a high school student, just don't fill it out at all, okay? If you're under 18, I might have a few that are under 18. Any questions about this form? You don't have to consent. I encourage you to, whether you consent or not, you're going to have to do the quizzes every Friday. And I'll need to get those back in today. The other thing that I'm going to hand out is just a slip of paper. On this slip of paper, I want you to write your name, your hometown, and something interesting about yourself. All right, it's just for me. I'm not going to distribute it to anybody. Excuse me. And while we're doing that, you're going to come up and we are going to take pictures of you. Yeah, I'm serious. Very serious. Okay? Because I like to learn your names, and there are 104 of you already.
I have a picture of Moodle.
No, I've seen your pictures on Moodle. They look nothing like what y'all look like. Listen, if you really don't like pictures, how do we link these out to this section?
I always like that one day of the week.
So the way this is going to work, who is it that I asked to do the thing? That was your... Yeah. Okay, so the way this is going to work is Daniel, Jonah, Dermot, Devlin, and Nicholas are all going to come up here, and they'll stand underneath. You can do like your mugshot if you want, or you can do your little thing or whatever. But y'all come on up. You know? And then, it's alphabetical, so you be prepared for the next person. And while you're waiting, watching them, you can fill out your little sheet. I know over here, Nicholas. Let's do this side. Over here, guys. So try to stand under your name. Over here, gentlemen. All right, Daniel or Dan or Daniel? Okay, Gerhard? All right. You ready? 1, 2, 3. All right, Gerhard, if you don't mind, just do the right arrow. Y'all get to see. You could just stand here and just do the right arrow, and that'll go to the next slide. Just when I'm done here. I mean, Shelby, Cameron, Jonathan, Rachel, and Maddie, fire. Over on this side, please. Y'all be ready for when your name gets up. You should know roughly when you're going to come up. Oh. Is it Madeline or Maddie?
Madeline.
Okay, Madeline. I'm sorry. I was thinking another Madeline. Okay. Is Shelby here? Oh, you're Shelby. So Shelby, you're under your name over here. Yep. Okay. All right. You ready? 1, 2, 3. Awesome. All right, Mark, you can go to the next slide. All right, Matt, Bertol, Matthew, Amy, Ariana, Taylor, and Alex.
Okay, Chandra, you know something interesting about me.
Are you a sibling too, Amy? You're about to All right, ready? 1, 2, 3. All right.
I don't know, it's okay to talk about
Right, go fast. Cameron, Francoise, Lysandra, Caitlin, and Jessica.
Not always on my phone.
Chandra? Okay. I'll try to remember. Just correct me. Okay. All right. Take it. Is it taken? Yeah. All right. 1, 2, 3. All right. All right. All right. Devin, Jacob, Ashley, Grant, and Kyle.
Oh my god.
And if your name ends in a C or E, please be ready to come on up. Ashley? Devin?
My favorite thing to do is mystery box. I don't know what's going on, like what they're writing.
And you all right. 1, 2, 3.
But I only answer my Chandra on the ship I'm very good.
Kira, Olivia, Caitlin, Nicole, and Kaylee. If your name starts with E, F, or T, y'all be ready, okay? You might even want to sort of line up your names coming up. Caitlin? Nicole? Kaylee? 1, 2, 3. All right. Benjamin, William, Megan, Evan, and Zoe. Your name is G-H-I. You ready to come up? William or what? William? Megan? Think about William, right? Okay. Evan? Evan, give me. All right, no Evan. All right. All ready? 1, 2, 3. Awesome. Thank you. Emily, Brittany, William. You have a Freddie, right? Freddie? And Emily Hermanson? And Emily? And Emily? William. Right, William? All right, ready? 1, 2, 3. Awesome. All right. All right, Alex, Caitlin, Kaylee, Benjamin, and Cody. Alan, Caitlin, Kaylee, Cody, Benjamin, Grenier, Benjamin. All right. 1, 2, 3. Well, too bad these people like to come. But I'll just sit on the floor. All right, Kayla, Margaret, Neil, Lingling, right? And Tanner. Do other people call you Lingling, or you just make that thing up?
Everybody calls me Ling.
All right. 1, 2, 3. All right. Awesome. All right, Morgan, Jordan, Sierra, Claiborne, and Madison. We're more than halfway done now. Madison or Morgan, Jordan, Sierra, Claiborne. All right. 1, 2, 3. Samantha, Tyler, Madison, Kim, and Shelton. Your name begins in what? K, L, N, or N. Please be ready.
Picture day at school.
Go about Madison.
Oh, there we go.
Madison.
There we go.
Sam.
There's the joint.
Or Sam.
So you really didn't know who I was? Stacy. No, you're talking about somebody else.
All right, Tyler. Kim.
That was my
Are y'all ready? 1, 2, 3.
I don't understand.
Whatever you want to do, I don't care. All right, Tanner, Amber, Ashley, Michelle, Rogan. Go first. Huh? No, you're first. Here. Here. Amber, Ashley, Michelle, Rogan. All right, 1, 2, 3.
Oh,
All right,
yes,
awesome.
yes.
All right, Carmen, Nicholas, Tyler, Amber, Petra. Tyler, right? This is Tyler, Amber. Carmen. All right. Ready, folks? 1, 2, 3. Okay, awesome. Jessica, Brooke, Son, Juliana, Caitlin. Jessica, Brooke, Juliana, and Caitlin. And Hassan. All right. All right, folks? 1, 2, 3. Okay, Connor, Rustin, Drew, Caitlin, and Myosha. Am I saying that right? Myosha?
There, right.
Connor, Rustin, all right, 1, 2, 3. All right, Kinsey, Marco, Raven, Matt, Matthew, and Anna. Matt, Matthew, Anna, Raven, Marco. All right, here we go. 1, 2, 3. Macy, Megan, Maddie, Madison, and Jessica. You're Mason. You go about Madison or Maddie? He's probably one. Just have a lot of Madison. Jessica. Are y'all ready? 1, 2, 3. Awesome. All right, just a few more. Sarah. Okay. Is that what people like? Oh, I see. Sarah. Bridget. All right, you're Brenda. Caleb. Betty. Awesome. All right. You ready? Okay. 1, 2, 3. And Joy, Tyler, Fallon, Angelina, and Savannah. Savannah? Joy, am I saying that correctly? Fallon? Angelina? Is that what people call it? Angel? Correct if I get it wrong, okay? Tyler. 1, 2, 1, 2, 3. All right, it's the last one. Justin, China, and Brock. Brock? Justin, China, am I saying that right? All right, Ready? 1, 2, 3. Alright, folks, anybody that did not get? If you weren't on this list, that means you're not on my Doodle page, so please see me if that's the case. And I need to take up all those papers, so I should get 2 papers from everybody. Why don't you send it back? Is that okay? Okay, sending it back. And I'll pick it up in this middle row. Oh, are there any extra little squares of paper? I don't know, Blanco. Yeah. There should have been lots there. Consent form? Yeah, obviously. Hey guys, extra consent form? My Blanco did not work very well. Anyone else needs a consent form? Please put if you were handing them to me, make sure that consent form is separate. Guys, I give everybody's consent form and your little introduction thing. Everybody got that? We have about 15 minutes left. We're going to start on chapter 1. Listen, it is my philosophy, I guess, that you guys spend a lot of money to come to class, and so I'm going to, when you come to class, I'm going to keep you the whole time. There might be some days during the semester when I cancel class or various, like I have a meeting or whatever, or if at the end of the semester we've covered all the material, then we'll just take a day or 2 off. But when you're here, we'll stay for the entire duration. So don't ever expect to get let out, except in, inordinate circumstances. Okay? If you come here, might as well work while we're here, right? Did everybody get a consent form? Did everybody get one and fill it out? Okay, it's kind of more about playing than I thought it was. All right. This first chapter is going to be, well, gosh, I say easy, but I always have students that have difficulty with it, so maybe it's not fair for me to say that it's easy. This is what your workbook will look like when you get it. It'll have the notes as we go through them. First bit is on standards for length, mass, and time. If we're making measurements as scientists, it's very important for us to have a standard for both length and mass and time, or whatever it is that we're measuring. So we're going to talk a little bit about how we determine what we measure length, mass, and time in, and then how we determine what the length, mass, or time of those measurements are. What is it that we're comparing? Right? In medieval times, the standards were sort of human-based, right? Like you had a hand or you had a foot, and those were not consistent. But as we begin to collaborate together as scientists, as many of you are, and many of you are biology majors, as we begin to collaborate together as scientists, we have to have a consistent way to measure physical attributes of things. So we're going to talk about the standards for length, mass, and time. These are all going to be in the SI system. SI stands for Système International, or the International System. It's French. Is there an E at the end? I'm not sure. Let's say there is, so it looks fancy. But it's the SI system. You're probably familiar with it. You should have been introduced to it even in middle school or whatever, elementary school. But if you're not, you can get familiar with it now. The SI system that we'll be using, a particular sub-branch of the SI system, is the MKS system. That's as opposed to the CGS system, which some of you might use, say, in chemistry, or if you're an astronomer, use the CGS system. It'll become apparent to you what these mean in just a second. So the measurement that we use for length is the M part. What is the unit of measure that we use for length in the SI system? It's the meter, right. So that's where that M comes from. It is the meter. And this standard has changed over time. I want to do a little bit of history on this because it sort of illustrates what makes a standard useful. What are the attributes of a good standard? In 1799, the standard was 1/10,000,000th the distance from the equator to the North Pole. Now, that's kind of not a very accurate measurement because it's very difficult to accurately measure the distance from the equator to the North Pole. Where is the equator? Where is the North Pole? So this is not a very accurate means. But up until 1799, it was accurate enough for what we needed to measure distances far. Today, it wouldn't cut it because we need to know distances to a much greater accuracy than that standard allows. Until 1960, the standard was the length of a particular bar. This bar happened to be in France. That's where the SI system is housed, or where where the center for it is. Not like a bar like you might go out to on the weekend, but a bar like a metal bar. And they had a metal bar, and they said, this bar represents a meter. Everybody henceforth will define their meter based on this bar. Okay? That's not real useful because, well, it's not really accessible. It also might not be constant. Like, we'll see actually that these physical constants can change. So we'll talk about it in a minute with the kilogram, but this bar can maybe change length depending upon its temperature or depending on various attributes of it. So it's not accessible, and it's not necessarily unchanging. All right, so these, I'll write these again in just a bit, but these are the properties of a good standard, that it needs to be accurate, it needs to be accessible to scientists around the world because we collaborate, and it needs to be unchanging. Over time, it can't change. Now, the standard, which is a more modern standard, is the distance light travels in a particular amount of time. That time happens to be 1/3 times 10 to the 8th seconds. That 3 times 10 to the 8th, that is the speed of light. And so if you take the inverse of that, that's going to give you the time that it takes for light to travel 1 meter. Okay? This standard, it is very accurate because we can measure the speed of light to great accuracy. So therefore, we can measure the meter to great accuracy. It is accessible. Everybody here could measure the speed of light. It's not hard at all. You need a laser, you need a motor, and you need a little mirror, and then a rotating mirror, and then you can measure the speed of light. It's actually a simple undergraduate experiment. Unfortunately, we don't do it in this class, but in a class above, you would measure the speed of light. So it's very simple to measure. It's very accessible. And also, as far as we know, the speed of light, it does not change. And so this is an unchanging standard. So that's a good example of how the standards have progressed over time, and then also how a good standard fulfills these three properties. Mass, on the other hand, has not progressed in quite the same way. The current unit of measurement for mass, remember MKS? I said this earlier if you call it. What is the unit for mass? The kilogram, right. Remember, or maybe not remember, but you'll need to know, and I'll write this later. Kilo actually means 1,000, so a kilogram is actually 1,000 grams. You'll need to know the metric system really well this semester. If you don't know it already, spend some time in the next couple of days just pounding it into your brain. The standard now is a particular cylinder in France. So this cylinder, it can give us a fairly accurate measurement for what a kilogram is. So it's accurate, perhaps. They can measure the mass of it very accurately, and then they say, okay, this is a kilogram. Henceforth, if you want to know what a kilogram is, it's based on this cylinder. But it's not really accessible. You guys couldn't go out and get that cylinder. It's under lock and key. They give copies out to other institutions around the world, but most part it's not accessible, not like the speed of light is, for example. And it also turns out that the mass of this particular cylinder that they have in France is changing. I have a video I'll show you about that in just a second, but they're trying to create a new standard for the kilogram that is based on the mass of a silicon atom. So the kilogram is losing mass. Hold on just a second, let me see. The kilogram is losing mass, so they're developing a new standard based on the mass of a silicon atom. What they're doing basically is they're creating a sphere, a ball. They have a ball about this big, and they get it perfectly round, and then they say, okay, this ball is a kilogram. They measure its mass, and they figure out this thing is exactly a kilogram. And then they count the number of atoms inside that silicon sphere, and then they say, well, 1 kilogram is equal to that particular number of silicon atoms. I'm going to show you a video now where they describe it in more detail. Y'all ever listen to the Veritasium channel on YouTube? It's a good channel, right? Ben, right? Yeah, that's it. I respect you a lot more now. You said that. Veritas, well, you'll see a lot of their videos. It's very good. You should check it out on YouTube. They have a lot of cool stuff about physics and biology and chemistry and what have you. But let's watch this video. We're not going to watch the whole thing, but it'll probably take us till the end. So if you want, you can go and put away your stuff if you want. Once we finish this, we will wrap up. Oh, we go to 11:40, though, don't we? Or 11:45. Oh, shoot. I always forget this. Well, we will watch just a couple minutes.